Up next are going to be functions and restrictions. So just to remind yourself, of course, a function always has to pass a vertical line test. So these up here are functions, that's a function, that would successfully be a function, that fails, and that fails to be a function. Now factoring is actually going to help us reduce the complexity of an expression, and this is actually good news. So suppose we have the fraction 10 divided by 50. We know if we write that in factored form, it's a simple example of course, but 10 times 1 and 10 times 5, we know that we can divide out common factors on the top and the bottom. So once things are factored, that allows us to write things in a simpler form. We know 10 over 50 and 1 over 5 is the same number, it's the same value. They're both equal to 0.2. If I put that into my calculator, I get 0.2 on both of them. But this is a simpler form because the numbers are lower. So we like that. That's what we mean by a simpler form. Now to do this algebraically, when we are reducing rational expressions, we need to be careful also of what we call the restrictions. And we may actually create a version of the polynomial that's missing some key information. So what we're actually paying attention to is this idea of division by 0. So I look up here and I say, the restriction is what can x basically not be allowed. So if I have 15x in the bottom, I can't have x equal to 0 because if I put in 0, 15 times 0 is obviously 0. And I can't have a 0 in the denominator. I don't care about the top. The top is fine. The top, I can have a 0 up there, but not down in the bottom. So the restriction is just going to be a statement of what I'm not allowed to have down in the bottom. Now, to continue working through this question, I can do a little common factoring in the top, a little common factoring in the bottom, and the question is kind of rigged, so I get this common factor of 3 in the top, 3x in the top and 3x in the bottom. As always, these common factors divide out, and that leaves me with 4x over 5. Okay, the point is we want to be able to do our restrictions first. Okay, we want to do them first because through our operations, we might actually wipe out part of our expression that we need. You see the x is here, but the x is no longer down here. So we kind of lost that information that we need for the restriction. So restrictions first, and then we simplify after. So again, we want to reduce this expression. We know it's tempting. We see, an x here and an x here, and we want to be able to sort of cross those out, but we can't because we have this negative sign here. This isn't factored, so we can't reduce this because it hasn't been factored. So we factor it. So at the top we can't do a lot. 3x is just 3x, but the bottom we have a common factor of 2x. So I take a common factor of 2x out, and now I say, okay, my restriction, I take a look at the bottom, I have this bracket x minus 5. So I know, and I have this 2x. And I say, well, what can x not be equal to? So it's okay to factor first before you do your restrictions. That's fine, because by factoring, I haven't sort of crossed anything out yet. It's all there. So I say, well, x can't equal 0, because if I put a 0 in here, 2 times 0 is 0. 2 times 0 would be 0. I can't have that. Or x can't equal 5. Because of this bracket, I have x minus 5. If I put an x in there, I would have, a 5. 5 take away 5. That would be 0. So I actually have two restrictions because there's actually two cases I need to take a look at. So that's the idea of restrictions. Okay, and once we're there, once it's finished, I take a look at the top, I take a look at the bottom, the x's divide out, and that leaves me with my final expression. Here with factoring, of course, we can look at our trinomial on the top and our difference of squares in the bottom. I factor the top, I factor the bottom. My restriction, I see, okay, I can't have positive 6 because of this one. 6 take away 6 is 0. And I can't have negative 6 because of that one. Negative 6 and positive 6 is 0. So I'd have two restrictions here. That's fine. I would divide out the x minus 6 in the top, the x minus 6 in the bottom, and I would have this, x plus 1 over x plus 6. Now, I'm going to graph this. Let's take a look at this graph for a second. If I were to graph it, what I'm going to notice is that the actual graph has a hole over at x equals 6. If you put this in the Desmos, you'll see it. There's actually a hole over here in the function, which is a little weird. And where that comes from is this. if we ever have matching binomial factors, so if I have an x minus 6 in the top and an x minus 6 in the bottom, that's going to create a hole in the graph at the corresponding coordinate. So which is a little weird because I have x minus 6 over x minus 6. So in my graph, the hole is here at 6. And what does that mean? Well, this is where it comes from. If I plug in 6 to this, I would have 6 take away 6 over the bottom, 6 take away 6. I would have 0 over 0, which is this really odd expression for us to deal with. So what happens graphically when we have this 0 over 0 is this hole gets created in the function. That's what's happening. Because of that, because I had this x minus 6 over x minus 6, that's why this hole was created. So if I had an x minus 4 over x minus 4, then over here at 4, I would have had a hole in the graph. So it just comes from when these things match, the top and the bottom. That's all. So we're just going to keep track of that and be aware of it as we go. And that's it.